Hello, everyone. Welcome to today's webinar, Simplifying the Developer Experience, Build and Deploy from Docker straight to AWS. I just want to thank everyone for joining today. Hopefully you're having a great time watching all of these sessions and learning a lot. My name is Carmen Puccio. I'm a Principal Solutions Architect here at AWS. I work within the AWS Partner Program, specifically with our container partners. I've been here for about 4.5 years now, and before I was in this role, which has been about 2-ish years, I was part of the AWS Mass Migration team, figuring out how to move workloads over to scale or at scale for our customers, working with our consulting partners and working with our technology partners to essentially make that journey easier. I hope today's talk resonates with you because, again, we're trying to make the developer experience easier for you. But I'm pleased to introduce Chad Metcalf. Chad?
Thanks, Carmen. So yeah, my name's Chad Metcalf. I am an architect at Docker, and I work with our cloud partners on sort of figuring out what that better together story is. I've been at Docker for almost 6 years, so I've seen quite a lot of the changes at Docker and how folks use Docker and what, watching that growth. It's been really exciting. Before Docker, I was more on the infrastructure side. So I worked at Puppet for a while. I ran infrastructure at Cloudera for a while. Going way back in a long time ago, I was a developer. And I'm really excited to be able to show you what Carmen and I have been working on for the last year.
Yeah. So if you missed it in the keynote, we're going to talk about it at length here, but essentially we're talking about a new experience for you as a developer, how you can take your workloads locally from your Docker environment and how you can get those workloads deployed into AWS in a very simplistic way. So we're going to go into that in depth, but before we do that, I just want to talk a little bit about AWS as a whole, the developer experience, and then we'll let Chad talk about the Docker pieces as well. So just to kick it off super high level, you've probably seen this slide before. I call this the innovation flywheel. And I don't want to spend a ton of time here. I really want to essentially talk about it this way. Think about how quickly you can experiment, whether you're building your workloads inside of your environment, locally on your machine, or you're building them out in AWS in the cloud. The goal here is trying to figure out how you can be as quick as possible to market. You want to be able to experiment. You want to be able to collect feedback. You want to essentially do this because it's going to help your business, right? Businesses want to drive growth, and they want things that are repeatable. They want processes and patterns, but at the same time, they want to maximize their value as they modernize their applications. So again, the faster you can collect and analyze that feedback, the quicker you can react to your customers' demand. And the more you essentially do that, you can potentially reduce costs. It allows you to essentially experiment on net new ideas. And the goal is to essentially get these things out as quick to market as possible because you want to be as successful as possible, but you also want to have this comfort level that you know that what you've done is essentially repeatable and tested. And that's hopefully, to be honest with you, that's what we're trying to talk about today is how you can do things in a very quick and easy fashion from your local environment as you deploy it to the cloud.
Yeah, and I think that is also the theme of this beta. So Docker is something that's been around for a long time. People rely on it for their production workloads. And so sometimes it's hard to experiment inside of a piece of software like Docker. But it turns out that Docker has a plugin architecture. And so as part of this beta, we're going to ship this beta as a plugin. And that allows us to decouple it from sort of the larger Docker and get this out faster so that we can get more community feedback and hear from you, like, what do you expect? And how would you want to use this? And that decouples that. But it also means that the experience that you're seeing right now is slightly different from the experience that we're going to be seeing when this goes GA. When it goes GA, the desire is that you're just going to see Docker run, Docker compose, all of those pieces. Today, you'll see a plugin, so it's going to be slightly different, but that's because we want to hear from you and get this out to you as quickly as possible.
So when it comes to the benefits of containers, it shouldn't necessarily be a new topic to you. Again, the cool thing here is thinking about how are you packaging your code? How are you taking the configuration files, the dependencies, and how are you moving it from any environment, whether it be your local laptop or into the cloud? And again, that's the experience that we're trying to emphasize here today. That standardized packaging and that fact that it runs locally on my machine, you want that exact same behavior in AWS. And the thing that we're going to talk about here at length is there's a lot of things to get that application running inside of AWS that we're trying to make easier for you. So again, you're still taking advantage of all of the things like built-in versioning and dependency declarations that you see here. But what we're trying to do is to make it a light lift. So you can take advantage of those benefits. And then at the same time, you can take advantage of the AWS cloud in a very, very easy way to get that application running from your local desktop into AWS, essentially with a simple up command. So with that said, we have a wide suite of container services here at AWS. We're specifically going to talk about Amazon Elastic Container Service, or ECS. And also on top of that, we're going to talk about AWS Fargate. The thing that I want to talk about here, though, just to emphasize, is our goal is to make this the easiest place for you to run your containers as a customer. So again, we have multiple options. The thing that's super cool is our services are deeply integrated with the AWS cloud. So you're getting benefits like IAM security, VPC networking, load balancing, and essentially, when you think about you're building your application, you have to set those things up. And we give you things like CloudFormation that makes that easier. But at the same time, that's a net new skill for your development teams to learn. And if you're just getting started with containers, you have to learn the primitives of containers, and you would also have to learn these constructs. What happens if we make this super easy for you and we allow you to deploy those workloads in? And that's the goal of the beta, and that's what we're trying to emphasize here today. So I just want to double down on ECS because again, that's the first service that we're integrating with. ECS, or Amazon ECS, is our fully managed container orchestration service that's allowing you to easily deploy and manage and scale containerized applications on AWS. So you're not necessarily worrying about installing or operating your own container orchestration software or managing it or scaling that cluster or virtual machines. Amazon ECS is designed from the ground up to be deeply integrated with the AWS platform and do a lot of those things for you. So it's going to work with things like application load balancers, IAM, ECR for pulling images, CloudWatch, CloudFormation, and even CloudTrail. And again, if you think about it, these are the core primitives that you need to get this application up and running. You want to have all of these things set up in a very prescriptive way, right? And again, to the use cases that I was talking about before, we're going to specifically talk about a web application today, but that doesn't mean that ECS doesn't work on things like AWS Outposts. We do see customers running machine learning workloads on ECS. And again, there are use cases with batch processing as well. But in our simple example today, we're going to do a web application. It's going to be highly available across multiple availability zones. And again, it's going to take advantage of those services that I was talking about, or those out-of-the-box integrations around networking and security and application load balancers to get you up and running in a very quick and efficient manner. So the beta specifically works with Fargate, and I want to be clear here. So Fargate now is ECS or it's EKS. So when you hear Fargate, it's not just ECS anymore. It could be either or. Our beta is again ECS based, and the thing to focus on when we talk about Fargate is you're focusing on building and operating the application. Right? You're only interacting with the container, and you're not worrying about any of the operational overhead from essentially the instance level. So you're not worrying about patching a server or thinking about the security of that server or management of that server. Fargate is doing all of that for you. It's always up to date. It always has the latest or required patches for you. It has some cool options around right sizing or flexible pricing options, if you will. It does have an on-demand option. It has an option around spot. And the thing that our customers do love is its secure isolation by design, meaning that whether it be ECS or EKS, the pods or the tasks each run in their own dedicated kernel runtime, and they don't share things like CPU or memory or storage or network resources with other tasks and pods. And again, this ensures that your workload isolation is improved security for each task or pod. So with that said, I want to kick it over to Chad. I want to have him talk a little bit about Docker and essentially talk about what we've built here today, and then we'll get into the demo.
Yeah, thanks. So lots of people have heard of Docker, the technology, and most people understand that there's Docker, the company behind that technology, but let's just talk about Docker Inc. for a second. So really the focus of Docker Inc. is developers and developer teams. So what can we do around Docker, the technology that everybody uses, to make that a more collaborative environment for teams of developers and make them more effective. So individual developers find lots of value in Docker and Docker Desktop itself, and then teams find value within like uh, routes to onboarding and faster onboarding, or putting sort of golden images into Hub, which is our SaaS product, potentially automating that workflow by tying it into their CI flows and having a central repository for, artifacts that are important to them or base images. And then that collaboration, sort of the team environment, I'm on the red team and on the blue team, and that means I can see these pieces or not those pieces. Sort of all of those things that you need when you have teams of people working across is the kind of features that you would find in Hub in our SaaS product. And then that ties in to Docker, the open source or the product like Docker Desktop, and making that a seamless environment for you developer to get your job done. So let's talk a little bit about the beta that you're going to see today. I like to think about it as it's just an extension of the Docker that you already know. So if you think about the Docker you already know, you probably are familiar with things like Docker Run. I want to run a container, or Docker Compose. I want to have two containers that talk to each other. One of them's a front end and one of them's a back end. I'd like to expose a port, and the front end needs the back end to be up. And I just want to Docker Compose up and have that work. And traditionally Docker has thought about the run time as an engine. So I want to run against my laptop, or I want to run against an engine running on an EC2 instance, and that, or potentially, sort of an orchestrator like a Swarm or something. But what we realized with talking to our customers is that a lot of folks, they just want to be able to run Docker against anything that knows how to run containers. And so what you're going to see today is one of the first steps in that. So you should just be able to Docker run against ECS, and you should be able to just Docker compose against ECS, and have that just be a seamless experience where you can use the tools that you already know, the tooling and automation you've already built, and just run that container somewhere else. So that's what we're going to see today, and it's going to be as simple as compose up. And usually simple is hard because there's a lot of complexity under simple. So we've worked together with AWS to take that complexity and manage it for you. In terms of when you hit Docker up, we're going to build everything you need to have that environment up and running. And Carmen's going to talk a little bit about what all that magic is.
Yeah, for sure. Yeah, so if you think about it, it's super simple to get started locally on your machine, as you can see here, right? You're doing a simple Docker Compose up, and you have a simple front end and a simple back end. But the next step, and essentially where we wanted to make things easy for our customers, is how do you get it to AWS, and specifically, how do you handle all of the surrounding constructs that are needed for that application to run? So even though we talk about AWS Fargate being essentially a managed service, where a lot of times we'll talk about it in the serverless context, you still need some of the key primitives in order for that application to run. So how would I create things like a VPC? How do I actually take my compose file and map it to something like a task definition, which is essentially your blueprint within ECS or Fargate? What about a concept like IAM, which is how we essentially secure our workloads in AWS? All of these things are essentially a net new skill sometimes for somebody who's new to AWS, or they have to go and create a secondary resource in something like a CloudFormation template to get that Docker image that you've essentially deployed locally to run inside of AWS. And wouldn't it be cool to essentially, like Chad said, do a Docker Compose up, and those things just appear. And when I say they just appear, they're created for you along the lines of what we feel are a great starting point or a prescriptive starting point for you to get your application up and running. And that's essentially what we're going to show you here today.
So, if you think about what Carmen was talking about, I like to think of it as the developer commute, right? There is going to our jobs every day. There is a commute, and there are a bunch of things that we have to do just to get to the office. And in technology, there's just a little bit of extra commute, right? I need to get the compute resource up and running. I need to understand this file format. And as technology gets more complicated, this developer commute tends to get a little bit longer. And so you have a few more steps, a few more exits on that highway before it's time to get off and actually do your day-to-day job. And so what we're hoping to do through this integration is simplify that developer commute. So ECS becomes a part of the Docker experience. It becomes a backend that Docker knows how to deploy to. So that when you say, I want to run this container, Docker is going to ask you, where do you want it to go? And if that answer is local, great, I'll happily make that happen for you. And if the answer is remote, I'll do that as well. And there is some amount of differences, right? So like potentially like where am I going to get the image and what's the underlying technology for the backing store. But you shouldn't have to know that, because in the end, you just want to know that you're going to run 3 containers and A talks to B, B talks to C, and C just happens to be a database. And so what we think this is going to allow you to do is stay in the tooling that you already know and you can be very productive in, and get through that inner loop as fast as possible and iterate quickly. One important step to this is Compose. And a precursor to the work that we were doing with AWS was open sourcing of the Compose specification. So Compose has been with Docker for a long time. I remember when the folks at Fig, which is the previous predecessor to Docker Compose, joined Docker, and it went from Fig to being Docker Compose, and that was a long time ago. And Docker Compose has always been part of our stack and our technology, but only recently did we break the spec out and make that open source so that lots of folks could participate. And so Amazon was an early adopter, early participant in that community, helping us understand how to extend the Compose specification beyond just a Docker engine. And so what you're going to see today, you'll see some extensions to Compose. You'll see some things that are different. And going forward, you'll see more of that as Compose becomes more and more agnostic as to the end time or the end runtime. And like I said in the very beginning, this is just the beginning. So I'm sure there's going to be lots of questions about like, well, what about EC2 backed instances, or what about sizing? Can I change sizing in Compose and all of these pieces? Lots more coming. So what you're seeing today is just the first beta, the first step in getting started. We want to get it out into your hands, getting folks using it, understanding, what folks want to do. And then, yes, and there'll be a public roadmap and a GitHub repository for you to chime in on all the things that are important.
Yeah. I think it's a little bit of eat your own dog food, right? So we're talking about that flywheel, right? And how fast we can get feedback. This is one of the great things. We want to put it out there. We want to put it in the public's hands. So essentially they can get their hands dirty with it and tell us what they like, right? Like, so again, like to Chad's point, there's a lot on the roadmap. There's a lot coming soon. You can see right there, for instance, EC2 launch type support is on the roadmap. We will be working on that. But again, we wanted you to get your hands on it as soon as possible. So super exciting stuff.
So let's talk a little bit about what that experience is going to feel like when the beta lands. So you're going to, the first thing that you're going to need is you're going to need a context. And so we introduced context about a year and a half ago. And originally it was about engines. So I have an engine locally, maybe I have an engine in EC2, and I want to switch between them. And I want to switch my context. So I have a local context, I have a remote context. And the work we're doing with AWS is to make ECS one of those contexts, so that you can say, oh, I want to start local, and now I've done that. I'm comfortable with what I want to do here. I want to just switch where the Docker CLI is pointing and have that exact same experience. So today you're going to see the plugin. So you're going to see a lot of Docker ECS this command. Like I said, at GA, it'll just be Docker run or Docker compose, but for the beta, it's going to be Docker and then the plugin. So you're going to see a lot of ECS. You'll see ECS setup, which is how we're going to get a context. You'll see ECS compose up and ECS compose down, and that's how we actually are doing a lot of this work. You'll also get the flow for how we get credentials. We just take your credentials from your local environment. So your .aws directory, we can pull out profiles. We can, I use a SAML authenticator to help me sort of set up all of my credential files and my environment variables. You won't see that on screen, but you will see the sort of the results of that. And then we are going to launch this into ECS back to Fargate, and we'll be able to go to console and we'll be able to see all of these pieces and see it running live here in just a moment. And we'll also see the cloud formation. Literally, we will see both the stack and we will see the cloud formation, which I think gives folks a path beyond just development. So if you've got operational teams that use CloudFormation directly, you'll be able to give them the exact CloudFormation that you're going to be using behind the scenes in the Compose workflow that you are going to have. So for the demo today, we're going to have a fairly simple front end, back end. We're going to be pulling images from Docker Hub from both a private repository and a public repository. We're going to have a developer CLI running on Docker Desktop on a Windows 10 box. And we're going to see the context and see the flow and see it go straight into ECS with Fargate. And it's really, I think, one of the things I like best about this integration is how plumbed in it is to Amazon. So we are using CloudFormation under the covers, which means when you do Docker Compose up, you're going to get a CloudFormation stack. Everything is going to be self-contained within that stack. So everything that you need, the VPC, the ECS cluster itself, Cloud Map, all of those pieces are going to be contained in one spot that makes it easy. So when it's time to go home, you can just delete the entire stack and all the resources will go with it. No dangling resources, no meters to keep spinning, but also makes it really easy to track. So here's my application and here's the entire stack to go with that application.
Yeah, so to Chad's previous point, the super cool thing about this is, again, we're doing all of this under the covers for you with CloudFormation. We are giving that level of transparency so we can essentially output the CloudFormation file for you to essentially modify as you see fit. But when you do a simple Docker Compose up, we're generating that template for you based off of the Compose file. And what we're saying is essentially the reasonable defaults in there that map to essentially these AWS artifacts, if you will. And when you think about this, it's fairly wide, right? It's actually, to my earlier point, there's a lot of surrounding constructs that you have to think about. So the very first thing we're going to do is we're going to create a VPC for you. It's going to be across multiple availability zones with the subnets that you essentially need to get this workload up and running. Again, it's going to take into account, do you want to use the default Fargate cluster, or do we want to create a net new one? And again, this is all part of the setup when you set up your environment inside of the Docker CLI. And then it's as simple as it's like, I'm going to create these services. So in the case of the simple front end, back end service, it's going to create the things needed for that service to run. And one of the key things is the task definitions for each one. And it sets up things that are super cool too, like thinking about how it's going to essentially do inter-service communication. So we are setting up the Cloud Map resources for you. So essentially you can communicate over a simple name, as you can see here, like backend.nginxgo.local. You'll have the front end be able to communicate with the back end over a DNS name. And lastly, we do some plumbing as well at the IAM level and at the logging level, because again, you need the ability to see what this application is doing. You want to be able to look at the logs. So we create the IAM role necessary for the task to run. And again, when we're wiring up the task definition, we specify where these logs need to go and we output them to CloudWatch for you. Again, all of this is done under the covers for you inside of CloudFormation, but I hope you see how super simplistic this is. You're going from an up to this advanced stack. And I think it's a great entry point for customers to get started when they're trying to figure out how to get their workload running up in AWS.
And you'll be able to choose what tool is the right place for you to be. So if the right place for you to be is to be in the command line with Docker compose PS or Docker compose logs, then that's great. You'll be able to get it. So in this example, I can get the port, the IP address and the port of this exposed service, copy it directly from the command line and fire up a browser pointing to that. If the right place to be is in CloudWatch, doing some more complex filtering and running through the logs that way, then that's the right place to be. And you'll get the best of both worlds. And what I'm really excited about is showing you, the demo is just a handful of minutes, and in that time, we take an application, build it, deploy it locally, tear that down, build up an entire ECS cluster from scratch, deploy that same application to ECS, and then tear it all back down in a handful of minutes, because it is as simple as Docker Compose up and Docker Compose down. So I'm really excited about being able to show you the power of sort of attaching the simplicity of Docker with the power of Amazon ECS and the rest of the Amazon services. So let's go to the demo. And let's start by talking about what we're going to see, what application are we going to do. So if you remember in sort of the early days of Compose, the quintessential demo was a Python Flask app with a Redis backend. And that's what we've done again. So we're going to pull that out, and I'm going to open this file. You'll see that it's a very simple Python application. We're going to go grab we're going to go grab Redis on the backend. And this is one of those powerful things that I think people miss what the power is here. All you're asking for is the back end, and we're going to take care of the rest. You don't need to know about service discovery. You don't need to worry about IP addresses. We'll take care of it, and we're going to take care of it in the best practice way. There's going to be a cloud map. We're going to put an entire domain in there for you. We're going to plumb that into the container, and all you need to know is what your service is called. In this case, I'm looking for the back end on 6379. Once we get there, this application, when it's loaded, is just going to do one thing. It's going to push a timestamp into Redis, and then it's going to render an HTML page with all of the timestamps that are currently in Redis. And that's it. So let's go look at the Docker Compose file. So the Docker Compose file is also fairly simple. It's got two services, the front end and the back end. The front end is going to start, you'll notice it has a build step. That build step is going to say, when we're doing this locally, build the application directly out of the app directory. And when we run this in ECS, you'll see that there's a hub repo in here. And that's a private repo hosted on hub, because ECS can't see my local image cache. So I have to have the images in a place that ECS can talk to.
And you have essentially a net new, because this is a typical Compose file, but you essentially have a new entry in there around X. So maybe we could just talk about X and what that would mean to you as a developer.
Yeah, this is one of the things that's making me really excited about the future of Compose. So we talked about breaking the specification out and having Compose think about more than just sort of the standard engine, which is what it used to think about. One of the challenges there, though, is each backend, each orchestrator, each container runtime is slightly different. The information that they might need to do something might be slightly different. In this case, the backend for ECS needs to know my credentials to use Docker Hub. And so we don't want to hard code those things into Compose. We don't want to have a million different parameters and stanzas and this and that in Compose. It just makes it really complicated. And one of the most powerful things about Compose is how simple it is. But in order to do that, we added these X parameters. And what this is, it's a way to tell Compose the backend needs to know this, but you don't. So the backend can say like, oh, this is where the secrets manager is for the credentials to go get this pull request from. But Compose doesn't need to know anything about that. And so Compose can just focus on A talks to B talks to C, wire that up. And on the back end, the ECS backend can say like, oh, that's where the secret is. Go grab that from Secrets Manager. And so you'll see other X parameters as time goes on. You might see instance size or region or anything else that the backend needs to know to make that a little bit more that realize that container in that environment. And again, we're going to launch this on 5,000. So you just need to know where your service wants to talk, and we'll take care of the rest. And we're going to take care of that for the load balancer. We're going to take care of that for the security group. All of that will be taken care of for you. And the front end depends on the back end. And in this case, the back end couldn't be more simple. It's just Redis. And in this case, it's the Alpine Linux flavor, just to keep it small. So let's go and actually do the build. So we're just going to use Docker Compose for this. We're going to do Docker Compose build. You're going to see a standard Docker build here. Nothing special about it. We're going to do a Docker Compose up, and we're going to launch this locally. And what you see is it's just Docker, right? So here's the back end, here's the front end. It's running the logs, we're tailing the logs as we speak. The back end is up and running on port 5000. So let's go ahead and navigate to a browser and just see what happens when we fire up on localhost 5000. And so we do that, and we see a web application. Look, it's got a menu with a menu bar with some links, and I can click on timestamp and inject a couple of timestamps, and we see that hit the logs right away. And so that looks good to me, and I think I'm ready to take this application to the next step and run it in ECS. But first, let's maybe talk about a couple of things that we're going to need to do that. I'm gonna push this container to Docker Hub, to my private repository, just to make sure that ECS can see it. And then the next thing that we're going to need to do is let's just talk about the plugin for a minute, just so that we understand like what's available in the plugin. If I just type Docker ECS by itself, you'll get a help message. You'll see that there's a handful of commands in here: compose, secret, and setup. Those are the ones that you really care about. And so you remember we were talking about secret. I need a pull credential, and out of the box, we'll give you a command to make that easy. No need to go into the console and set up a secrets manager and figure out what roles do I need and what policies do I need to attach to. We'll just take care of all that for you. You just give us the username and password, preferably a PAT. Go to Docker Hub and get a personal access token just for this, so that you're not putting in your primary password. But you can inject that here, and then we'll take care of the rest. The next thing is we need to get the context, and that context, we're going to use the setup command for that. You'll see that I only have one context right now. It's the default context. That just happens to be my local Docker desktop. It's basically the socket. And so now I want to go grab an ECS context, and I'm going to hit setup. It's going to walk me through an interactive process to do this. By default, it's going to ask me for a name. Anything you want. I'm just going to use AWS because it's easy, just a couple characters to type. It's going to ask me for a profile. By default, we look inside your .aws directory and look at what profiles you have available to you, and we'll ask you which one of these do you want to use. I'm going to use the sandbox profile from today. It's going to ask you for a cluster name. So if you want to, you can use an existing cluster. However, you can just leave it blank, and we will create a brand new cluster for you. And this is one of those interesting things. It seems really easy or really simple in the beginning, but actually it's more than just a cluster. It lets you decide how you want to run your applications. Do you want to run multiple applications in the same cluster, or do you want to run a cluster per application?
Yeah, and what's super cool about that, and the way I always talk to customers about Fargate and the way that essentially Fargate works, clusters are nothing more than just a logical grouping, right? Like, so when you're thinking about where I'm going to place my application or where I'm going to run my tasks, It's completely normal to have a cluster per application. We see customers spin them up per environment. There really is no, wrong here, if you will. So again, think of it as essentially just this boundary where I'm going to place my application. And then, again, we're wiring the communication of your application for you, within that cluster. So in this simple example of front end, back end with the Redis, we're handling all of that for you after you choose your cluster.
And one of the things that I think is exciting about this as a development manager is that it scales to zero, right? So when I'm not running any containers, it doesn't cost anything to have a context for this. So I can come into work, I can Docker Compose up, do my job, Docker Compose down. I can keep that context, but because I have no containers running, there's no meter spinning. And it's going to ask me for a region. I just choose US West 2, just happens to be close to where I am. And credentials. I don't have to add credentials here because the tool is smart enough to be able to look at the credentials. If you needed to, you could bake them into the context, but by default, we'll just get them out of your environment or out of your AWS directory. Once I have that, I need to just Docker ECS compose up, right? Well, kind of. You'll see that when I do this, I'm going to compose up, but it's going to fail. And the reason it fails is because default is not an AWS context. And this is one of the things that I think is really exciting in this new world where Docker becomes more aware of the backends, and it knows that not all backends are the same. And in this case, the default backend is local and it can't deploy ECS resources. And I think you'll see this more and more where Docker and Docker Compose will be smarter about what it can and can't do depending on what you're asking for. So I'm going to just Docker context use AWS and switch. You'll see the little blue whale on the bottom right of my terminal switches to AWS. It's a little syntactic sugar for my terminal that helps me remember where am I about to launch this thing, so that I keep that in mind just in case I don't want to launch it to a remote cluster. And then we're going to Docker ECS compose up, and we're going to stand up this environment. And the first thing that you're going to see is some CloudFormation scroll by. Not the actual CloudFormation, just the logs, but we'll actually look at the CloudFormation here in a moment. And you'll see that we're creating a cluster for you. We've got some log groups, a bunch of IAM roles. And let's go look at that CloudFormation itself, because I think this is really also kind of a cool feature. So we have a command called Docker ECS compose convert. And what this does is convert a compose file into the resulting CloudFormation stack. And you can actually we're going to scroll through it, but you could actually fire up an editor and make changes and put in stanzas that you need in your environment. Or what I think the power is a path for maybe as a developer, I'm just going to use compose. I'm going to compose up and compose down. But at some point, I might hand off to a team, maybe a production team that uses a different tool chain where CloudFormation is in that tool chain. I can take and give them through this one-way gate a path so that this application, I'm not making them figure this out for them. I'm going to give them the path that takes them on that step for their journey. I think that's super powerful. Let's go look at the console, because I think we've seen a lot in the command line, and we were talking about before. Let's go see the different things you can see in the different places. So I'm going to go just fire up the console and go to CloudFormation. We'll look at the stack, and then I'm going to pull a couple of key resources I think are fun to look at out. The first thing I'm going to do is I'm going to pull the cluster out so that we can go look at a task definition. I'm going to grab the log group so we can watch the logs. I'm going to grab the security group, and let's start with security group. So I'm going to look at the inbound rules, and we're going to see port 5000 is open, right? Don't have to do anything. It's just there for you. I'm going to go look at the backend task definition, and we're going to fire that up so that we can see the JSON for that. And this is one of those really interesting pieces. The task definition is a super powerful tool. There's a lot you can set in a task definition. There's also a lot you need to know to set a task definition. And so as part of that power of Docker, making simple things for our users, we're going to take care of that. So if you're using Compose or you're using Docker Run now, you don't need to know all of those pieces. We'll take care of that. The power is there so that further down the line, if you need to tweak some of those knobs or you need to inject some extra parameters, you'll be able to do that. But out of the gate, if you're a developer, you just want a Docker Run or you just want to Compose up, and we'll take care of the rest for you. The next thing I want to do is I want to go look at, let's go look at the load balancer actually, just to see that, we've got one up, we've got one running. Auto scaling is not going to be in the first pass of this, but I guarantee it's going to be a question. It will be coming in the future. So the load balancer will be important. We'll make sure that those pieces are all there for you. Out of the first beta, we're focused on sort of like call it the 80-20 of Compose files. Like let's get that out, get folks using it. But we have a load balancer and we fully intend to take advantage of that. Let's go look at the CloudWatch for the backend and see the logs in CloudWatch. Go find that. So you'll see that we've got basically CloudWatch for both. Right now the backend is up, the front end's not up yet. So here's the same sort of logs that you would see for Docker Compose log. Now let's go back to the command line and see what else we can see. So Docker Compose PS. I have 2 containers running, and this looks very familiar for folks that have used Docker for a long time. What are my containers running and where are they exposing ports? In this case, the front end just became active and it is exposing port 5000 on this IP address. So in a minute, I'm going to copy and paste this IP address and launch it into a browser. But first, I want to get the logs up because I want to see that experience. And so let's do Docker ECS Compose logs. And what you see here is the exact same experience that we just had a couple of minutes ago when we launched it locally. I've got a backend, I've got a front end. The front end is on port 5000. So let's go browse to port 5000 and hit the timestamp button a couple of times and see what happens. So we're going to fire up a browser here, navigate to that IP address and that port number, and it's the exact same application. I can go look at the menu, I can go punch the timestamp button a couple of times, and we watch the log scroll in. And I think, it's the exact same experience. And this is where sort of that power of simplicity, the power of sort of portability that Docker has always had is now even better. So working together with Amazon to make that code to cloud path as simple as possible. And one more thing to show, sort of, there's other pieces in this. It's like a kid at Christmas. Every time I turn around, there's something new that I didn't know about. So Container Insights is up and running for me. I didn't even ask for it. I just know that it's there. I can go look at what are my containers, what resources are they using? Are they wonky because of my application, or is it wonky because of the resource that's going on? And the tight integration that we've managed to build together with AWS here and plumbing it all the way through, I think it's just really exciting to take the best of Docker and combine it with the best of Amazon Web Services. There's just one more step. So Carmen and I are done for the day. It's time to go home. Let's tear this down. So Docker Compose down, and we're going to tear down that CloudFormation and all of the different resources and scale that all down to 0. So in a couple of minutes, we deployed locally, built a ECS cluster from scratch, deployed again, and then tore it all back down. And that's really, I think, really powerful. So that's done for the demo, but there's a couple things I wanted to show. The Compose specification site here, compose-spec.io. There's an entire community. It's not just Docker. It's not just Amazon. There's lots of folks that are here talking about what do they need Compose to do for them. So, join the conversation here. I'm going to navigate to the GitHub page right now, and actually you can go read the specification itself. It's all in GitHub. There's always a pull request available to you. This is the X factor sort of chunk of that specification, just showing what's really in store there. What are we thinking about? How do we look to extend there? And then the last thing I want to show is one of my favorite projects at Docker. It's called Awesome Compose. Right now, it's about 30 different compose files for different tech stacks, and it's much like this. It's the best practice way to use compose with the language or with the framework that you want. And so go to Awesome Compose, find some compose, and launch it into ECS with this new beta. And I think that more or less concludes the demo for this.
And when it comes to next steps, in order for you to just get your hands on this, and again, we're looking for the feedback from the developer community. Take a look at the AWS blog. It'll be up on the containers blog, where you're used to seeing all of the container-related information that we put out. At the same time, Docker put out a blog today as well, and they cross-link to each other. Both of them have a link to the GitHub repo that'll give you a little bit more information that Chad can talk about.
Yeah, so in that GitHub repo, you're going to find the steps needed to install the beta in your Docker desktop. So Docker desktop for Mac or Docker desktop for Windows. You'll also find the demo that we did today. So the Redis app, or the Python, Flask, and Redis app, also with the flow that we did, so that you can reproduce step by step everything that we've done today and see it working for yourself in your own environment.
Awesome. So with that said, I just want to say thank you for attending the session today. And I just want to put a heartfelt thank you out to the Docker team and to Chad. It's been a long year, but it's been a lot of fun building this with you guys. It's super exciting. And, thank you very much for all of the collaboration.
Yeah, I'm excited. I'm excited to be able to talk about it, because it's been a long time coming, and I'm super glad to see it out there.
Okay. Well, thanks again, and enjoy the rest of the conference.
Cheers.
Take care.